Welcome to qnawire.
Hi, so the first thing that we need to do is to remember what are the approximate pKa's for different compounds. So for example, when we have carboxylic acids, the pKa is in the range of 4 or 5. In the case for alcohols, as in this one, the pKa corresponds to something in the range of 16. In the case for amines, the pKa is something around 9 to 11. And And in the case for the phenol, that is the one of the special ones, the pKa value for phenol is of 10. Okay. So with this information, what we can know is that if the pH is lower than the pKa, we're going to have the acidic form. And if the pH is higher than the pKa, we're going to have its basic form. So for the first compound, we have a pH of 8 that is way higher than the pKa. So we're going to have the conjugate base of this compound. For the alcohol, the pH is equal to 12. That is going to be way lower than the pKa, so we're going to have the acidic form of the alcohol. Next up, for this compound, we have an ammonium salt. In the case for amines, the pKa it's of around 10, 11, maybe 12 in some scenarios. So in this case, we're going to have the basic form of this amine, which is, in this case, let me erase this section. We're going to simply have NH, we lose a nitrogen, and we have the basic form of the amine. Next up, for this compound, in this section, nothing is going to happen, so I'm going to write down the phenyl group. Here I'm going to write it down as an R directly, because in this case we don't have any acid. And the pH it is going to be way higher than the pKa for a carboxylic acid. So we're going to have the basic form of the carboxylic acid. And finally, for the phenyl compound, we said that the pKa was of 10. So that means that we are going to have the acidic form of the phenyl compound, which is the phenyl as it stands, OH direct. So those are the forms that we're going to find these compounds. And that will be all. Thank you very much.